All right, last video. Just a couple more questions and then we are done. So number 20, what we're looking at here. And, it says, use scatter diagrams and linear correlation coefficients to determine if a relationship is linear. Make the best prediction relative to correlation. Understand that correlated data may not have a causal relationship. So, okay. A random sample of multiple story buildings is measured in feet. Is there a linear relationship between the number of stories and the height of the building? Okay, so it looks like across the top there we've got our years. Then our middle row here is talking about the height of the building, and then the number of stories is below that. Now, I just want you to know that not always is it in order of X and Y. It really kind of depends on what they're saying they want to predict, right? Because you could have the number of stories predicting the height, or the height predicting the number of stories. So it could really go either way on this one. So it just really comes down to the question and what you're looking at. So part A says, we will predict the height of the buildings from the number of stories. Okay, we are predicting height from the number of stories. So that means, there you go, like that. Okay, so based on this, which variable is explanatory and which is response? Remember, explanatory is going to be your X value. Okay, that's what's doing the explaining, right? So what are we using to predict the other thing? So our explanatory variable, explanatory is the number of stories. And the response, so that's what's being predicted, right? So what are we predicting here? And that's going to be the height of the building. Okay, calculate the correlation coefficient. So this is your chapter 4 stuff right here, okay? And if we want to calculate the correlation coefficient, I'm going to have a list. So I'm going to pause. I'm going to make a list. Just like with our matched pairs, these also are matched, right? You're using them to predict something. So the number of stories, predicting the height of the building. So when I put these in my calculator, I'm going to go ahead and put L1 as the number of stories. And I'm going to put L2 as the height, just so that they're in XY order. It just makes it a little bit easier for us later. So I'm going to pause. I'm going to go ahead and put these in. Remember, I'm going to put stories in list 1. I'm going to put height in list 2, and I am going to keep them matched up the way they are here in order to make, accurate data, right? So, okay, so I've got my stuff put in the calculator, and I'm going to walk you through, first of all, remembering how to turn on your diagnostic, because that's something you'll have to do on your own if you clear the memory of your calculator on the final, which you should be clearing the memory on your calculator. But it'll turn off your diagnostics, right? So if you have to turn that on, remember it is on your formula sheet. I think, oh yeah, I have the formula sheet right here, right? Don't I? Yeah, here it is. Yeah, let me show you. Under chapter 4, here it is right here. It says to turn on R. Okay, so when you're looking for your correlation coefficient, remember that that's R, and we have to turn on the diagnostic. So here's your steps right here. So normally, we'd be in class and I would say, okay, everybody clear your calculators, and then I would go through and make sure that everybody was able to do it without any problems. But this time, since you're all online, I can't do that. So it is on the formula sheet. So this is what you'll do. You'll do second 0, select diagnostics on, hit enter. Then it should say done on the screen when you hit enter again. So we'll go through that. Okay, so let's go to, second 0. And if you hit the, you see where I'm kind of circling here, this is the D in green, where it says X -1, inside matrix and whatever. If you select that button, what that does is it takes you down to where the D's are. That way you don't have to page all the way down to the D's. All of these green alpha buttons, it'll take you to any letter in the list that you want. So if you're like trying to figure out where something is on the calculator and you can't find it, this is where you can go to find. I thought day of week, I thought, that's interesting. I wonder what that is. But anyways, so if you just scroll down till you get to diagnostic on, Okay, now there's two of them, right? One of them says on, one says off. You don't want to turn it off. You want to turn it on, right? Hit enter. Hit enter one more time. It should say done. And now you're good to go. And it'll stay on until you clear the memory on your calculator again. So it'll be there. Okay, so we've got the diagnostics on. And now we want to find the correlation coefficient, which is R, right? So I'm going to go ahead and hit stat. And we're going to go over to calc. Been a little while since we've done that. Remember that number 4 is the linear regression equation here. AX plus B, right? That's the one we want. Number 4 for chapter 4. So linear regression, hit enter on that. Now I did go ahead and put the number of, the stories in list 1, like I said, to make this easier. So make that L1. And if you did not, and you put like the heights in L1, that's okay. You just switch these two. It'll be fine. So my X list is my explanatory variables. That's my stories. And then L2 is my response variables, which is the height. Frequency list needs to be nothing. And then you're going to hit calculate. Okay. So we've got our linear regression here. We've got an equation, and we've got an R squared, and we've got an R. R is the one we want right here on the bottom, right? And it's 0.8948. And generally, we round R to 3 decimal places. So in this case, that would be 0.895. There we go. So we'll say R equals 0.895. And that's that. Is there a linear relationship between the number of stories and the height of the building? So let's see. Whenever we determine if there was a linear relationship before, what we would do is we would look for the critical value on the formula sheet. And that's still what we're going to do, right? So I need to know, in order to find the critical value, what is my N? So how many different buildings are we talking about here? And I happen to notice, I believe it was 15 on my, when I was counting them up here, and I looked on my list, I saw that there was 15 entries. So N is 15. That's how many different buildings there are. And we need to find the critical value on the formula sheet. So let me show you how to do that. And I should have done this so long ago. I don't know why I didn't do this. Sorry, my videos could have been a lot better. Okay, so right here in chapter 4, you'll see your critical values table right here for the correlation coefficient. So I'm going to look for where N is 15. Here it is. N's 15 here. And I look over and I've got 0.514. 0.514. All right. Okay, and I want to compare the absolute value of R, which is 0.895, and I'm going to compare that to my critical value. So 0.895, is that greater than or less than 0.514? It is greater than. So if the absolute value of R is greater than your critical value, what do we say? We say that, yes, it's linear. Yes, there is a linear relationship. Okay, so let's find the linear regression equation. So for this one, remember that for the regression equation, it has to be y hat equals. So even though the calculator says y equals, we know that the linear regression equation is a prediction, and it should be y hat. So going back to our calculator here, you'll see that you've got your y equals ax plus b. This is your information right here, other than we know it's y hat, right? Our a is 9.726 or 9.73. I'm just going to go ahead and say 9.73. Actually, you know what? Let me, 9.73x plus 151.22. Okay, so 9.73. Don't forget the x. A lot of people forget the x because they don't see it on the, on the calculator, on the screen, in that menu or whatever. They just see the 9.73, they see the 151.22, and they just don't happen to notice that they need to put an x, right? If you don't put an x, then it's not really a linear equation. Okay, And then it says, if possible, make the best prediction for the height of a 26-story building built in the late 20th century. So 26 stories. So let's make sure, is 26 within our scope? I mean, I would say yes. It looks like it's in our scope. I mean, it looks like our lowest number here is a 28. But 26 is not far off from that. So I think we're okay. We can go ahead and predict it. So when we make a prediction here, we're going to say y hat equals 9.73 times 26 plus 151.22. So when we calculate that, we get, I just want to double check my work, 404.2. And we are going to round because we can't have, well, I mean, yeah, none of our numbers here are in decimals. So 404.2 is 404. So we would predict 404 feet. Okay. Still on the same problem, we have a question on the next page here. And it says, if possible, make the best prediction for the height of a 0-story building built in the late 20th century. Okay, well, let's start for a second. And I mean, just honestly think about this logically. Don't go, oh, I just plug in 0 and then I'm going to get an answer. Okay, think for just a second. If you have a 0-story building, does that exist? No. If it's a building, it has at least 1 story. I mean, it has to, right? If it's a building, if it's not a building, I mean, you can't have a 0-story building. This just doesn't even make sense. So, a 0-story building does not make sense. So, it is not possible to make a prediction on the height. Okay. So, so then this is our last question. Last question. So exciting. Okay. Following data represent the total compensation for 10 randomly selected chief executive officers, otherwise known as CEOs, and the company's stock performance in 2009. Compensation in millions of dollars is given on the top row of numbers, and the stock return and percentage is given on the bottom row of numbers. Okay, let me go ahead and just write that down. Let's see, what did it say the top row was? It says the top row is compensation, millions of dollars. So I'm going to go ahead and write this here. Compensation. Over here I'll just put millions of dollars. Okay, and then the bottom row, the stock return in percentage, right? Stock return. Stock return percentage. Okay. It says the requirements are met and the linear regression t-test results are below. So I think I actually... Okay, so here's the deal. On this question, I didn't cover this linear regression t-test. I didn't, because I honestly didn't feel like we needed it, and it's in chapter 14.1. And it just seems like it would make things more confusing, and what's the point, right? It's not on the final, and I just don't think that it's necessary. Now, some instructors, if you happen to be in another class watching this, may have taught this, right? So maybe their final has this. So that's why I went ahead and left it on the review. But I'll show you how to do this without using this linear regression t-test, okay? So don't worry about this linear regression t-test. We didn't cover it. It's fine. Don't worry about it. The only thing that you would be concerned about here, if you're dealing with linear regression t-test, is this p and this t, right? P-value and test statistic here. We don't need it, actually. We don't need it. So here's what I'm going to do. I'm just going to do that. Okay. and I'm just going to use everything else. Okay, now, so anyways, your questions may be a tad different if you're in someone else's class. Okay, it would be reasonable for a higher stock return to lead to higher compensation, right? Based on this, which variable is explanatory and which is response? Okay, so if we're talking about higher stock return leading to a higher compensation, then it looks like here, this one, which I didn't leave enough space here. Let me maybe abbreviate this. Compensation, stock. Maybe I should do just returns. I'll do returns. Okay, so it says higher stock return to lead to higher compensation, right? Which means the returns is going to be the explanatory variable X. The compensation is going to be the Y. Now, I know what you're thinking. Why would you guys make it confusing? Like, why not put X first and then Y second? You know, that's a good question. And on your final exam, I did. I put X first and Y second because I didn't want it to be confusing. This is how it is on the review. So, you know, draw attention to the fact that it could be that way. But on the final, at least in my class, they'll be in order. It'll be X first and Y second because I'm not going to try and trick you guys. Okay. So it would be reason. Okay. So based on this, which variable is explanatory? So explanatory is going to be the stock returns, and the response is going to be the compensation. Okay, state the correlation coefficient. Okay, this is easy. R equals negative 0.206. You're going, what? How do you know that already? Where'd you get that number? Well, it's right here. It just told me. There it is. All right. State the test statistic and p-value. Oh, for those of you in another class, let me not draw a line through that. Here we go. This is how you would do it. Test statistic is negative 0.596. P-value is 0.5678. We're not going to do anything with those, but there you can identify them. That wasn't that hard. Is there a linear relationship between the stock return and the CEO's compensation? Okay, so we can use critical value like we did before, right? So if n equals 10, let's go find the critical value on our table. So on your formula sheet, whoops, wrong one. Let me get rid of that. Okay. Formula sheet. All right, n equals 10. Critical value is 0.632. Okay, let's come back. 0.632. Okay, so let's compare. What is the absolute value of R? Well, absolute value of R is 0.206. You may be wondering why I made it positive. Well, absolute values, remember, make everything positive. That's what they do. So the absolute value of a negative number is now positive. So that's where the negative went. It didn't just vanish. I took the absolute value. And I'm going to compare this number, 0.206 to 0.632. Which one's bigger? Yes, obviously, 0.632. So if the absolute value of R is less than the critical value, then this means there is no linear relationship. Okay. So then it says, all right, if possible, make the best prediction for the CEO's compensation when the stock return is 6%. Okay. Remember that the numbers are in percentages, so you would plug in 6. This would be like the only time because it actually defined your numbers as percentages. But here's a secret. It's not really a big secret. If there is no linear relation, then what does this mean? This means that y hat equals y bar. Okay, so in this case, you actually aren't plugging in anything. You come back up here and you say, oh, wait a minute. Looky there. Here's y bar. That's your answer. Right? Y hat equals 17.317. So that was easy. If possible, make the best prediction for the CEO's compensation when the stock return is 50%. Oh, sorry, negative 50%. Does say negative 50%. Negative 50%. Is that within the scope of our data? So, I mean, let's come up here and let's look at our numbers. Do we have any negatives in percentages? Oh, we do. We have a negative 8.4. All right. But does it go as low as negative 50? And the answer is no. It's not even remotely close to this. Negative 50 is way beyond the scope of our data. So we can't even use this prediction to predict this value. So we would say that negative 50 is beyond our scope. Beyond the scope of the data, so we cannot make a prediction. All right, finally we did it. That's the end.